Hey y'all, we are here to do our last SOL review, some more work on how to use Desmos to help us with SOL type questions. And this time we're going to focus on quadratic functions. These are the ones with x squareds in them. And so one thing that we might want to do is evaluate a function. We've talked about evaluating using sliders, but another thing we can do to evaluate um, a function is to type it into Desmos. So if we get this notation where we have f with x in parentheses, this is read f of x, and we're looking to find f of 5. And remember, this is just a fancy way to say y. Sometimes you might see g of x or h of x. That's just a way to uh, denote it's a different function. And what we can do is we can plug numbers in for x uh, using the calculator. So if we tell the calculator what our function is, and then we go down and tell it what we want x to be by plugging f of 5 in here specifically, it's going to tell us what the function is equal to when x is 5. And that's another way to evaluate functions, in this case specifically for functions that are quadratic. Another thing we can do, much like we solved regular linear equations with just plain old x, is we can graph quadratic equations and find solutions. So if we want to solve this quadratic equation, we can plug it into Desmos, and then we go find the x-intercepts just like we would with a regular linear equation. Those x-intercepts are going to have x values of -3 and +3, and of course the y value is always 0 for an intercept. But to find the solutions, we find the x-intercepts and we take those x values, and they are our solutions. We also call these solutions roots, and we call them zeros. And those three things mean the same thing. What it means is go find the x-intercepts. So the x-intercepts are the locations. Go find those x-intercepts and then choose the x values of those intercepts. So they are the x values of the x-intercepts. So we solve anything really by graphing it and finding its x-intercepts, and then we choose the x value. And this is actually what I just wrote up there. Zeros, roots, and solutions are all the same idea. You find the x-intercepts, and then you take the x values. So if we want to find the solutions to this function, we would graph it, go find its x-intercepts, and then choose the x value. So in this case, -2 and +6. Those are our roots, solutions, zeros. So there's three different things. There's the x-intercept, that is the location of the point. The root solution zeros, those are the x values of the x-intercepts. And the other thing we can find from there are the factors. We use those x-intercepts, the x values, the root solution zeros, to find the factors. We would take parentheses and they both get an x. And then we take each of those solutions, each of those roots, each of those zeros, and we plug them into these parentheses, but we switch their signs. So -2 becomes +2, +6 becomes -6. And these would be our factors, much like is shown here already. So when we graph a quadratic function, we get a lot of information just from locating the x-intercepts. Sometimes there's 2, sometimes there's 1. So I'm going to do a few examples of SOL type questions here where we have quadratic functions and or quadratic equations and we want to find an answer. So the first thing to note is that quotient means to divide. Real quick, sum means to add. Difference is subtract. Product is multiplication. So here we're asking for a quotient of these two things. And so we're going to put the first one on top. And so when all else fails, what you can do is graph something. So let's graph this. Here I have it graphed, and we're not asked to find the solution, but if we were asked to find the solution, we could go here to the x-intercept, and the solution would be 1.2. But that's not what we're looking for. We're looking to know what do we get when we divide those two things. And so one of these things should be equal to this quotient. And so I like to, if I can get my answer by choosing the simplest one, that's what I'm going to do. So we can plug all these into Desmos and see which one matches up with this line. And so I'm just going to start from the last answer choice, 5x minus 6, because it's short. And hopefully it's my answer. And in fact, it is my answer. That blue line graphed right on top of the red line. And so that means that these two things up here being divided are equal to 5x minus 6. And you could see if I plugged in 5x plus 6 that it would be close, but they're not right on top of each other. So it's not the answer. And what's nice here is I didn't have to put all of them in. I checked one of them and it was my answer, and I am good to go. So whenever we're trying to see which answer choice equals the original information they gave us, we could just graph all that stuff and see which ones line up. If they lay right on top of each other, that means they're equal. For this one, I want to factor. So I'm going to graph this in Desmos, which I have here. And then I want to find the factors. Well, most of the information we get from a quadratic is looking at the x-intercepts. So I get x equals negative 0.667 and x equals 5. And of course, that's not what our answer choices look like. These are our solutions, but we're looking for factors. So we should have some parentheses. They'll each get an x. And then I'm going to take both of those solutions, and I'm going to put them each into a parentheses and change the sign. So I'm going to do positive 0.667 and negative 5. And so hopefully we can see one answer straight away, x minus 5. There is no decimals in our answer, so we're going to go change that decimal to a fraction. So 0.667 is actually 0.6 repeating. If you get 0.333, that comes from 0.3 repeating. We hit that fraction button and we get 2/3. So we're going to change this to x plus 2/3. I still don't see something that looks like that. And so the trick here is to take the denominator of that fraction, the 3, and put it in front. So this becomes 3x plus 2. And that is one of my answer choices. So I need to be careful here. You should feel pretty good if you get those two. We need to be careful. We need to make sure that we check our answer. We can check our answer by typing it into Desmos. Minus 5 times 3x plus 2. And if I've factored this completely and I factored it correctly, then those two lines will go right on top of each other. But in this case, they don't. I can see a green and a red. They're close. What that means is I've missed a common factor, a number at the beginning of this factored version. And so I have two options, 3 and 9. I'm going to try 9 first. I can still see both lines, so 9 is not the answer. If I put 3 in there, the green goes right on top of the red, and so that means 3 is also a factor. And so I would need to choose all three of these to have the factored version of my polynomial. This one here, I'm just looking for a solution. So when I'm looking for a solution, I'm just typing this into Desmos. You can type it in with the equal 0. I actually recommend that because when I put it in with the equal 0, it's going to graph just two lines, which makes it easier to see. And then I can click on the intercepts. My solutions are negative 1.5 and negative 1. I'm going to go ahead and change negative 1.5 to a fraction. -3/2. So again, my solutions are -3/2 and -1, and I just got to go find the answer choice that has those two values. These little curly braces, this is just set notation. That just means there's a set of answers. In this case, there are two answers that make this equation true, -3/2 and -1. Here we're talking about range. Range is how far our function goes up and down. Something you need to remember. So if you're trying to remember some certain information, it's a good idea to write it down a bunch of times and then put it on your scrap paper when you get to the test. So here I want to know the range. So again, I'm just going to graph this thing. The best thing to do is to graph equations if you're given them, and then hopefully that will help you find an answer. So it says that the range is all the numbers, all real numbers greater than or equal to. And so what we're looking for is how far up and how far down does this function go? It goes up forever, and the furthest down it gets is 3. So a y value of 3 at my vertex is as low as this function goes. And so my range is all numbers greater than or equal to 3. And it happens to be a choice right there. 2 is also a choice. 2 is wrong because 2 is the x value. It tells us x values tell us how far we go left to right. 3 tells us how far we go up or down. In this case, up. All our all our points will be above or equal to 3. One other thing we can do is look at a question like this where there's multiple answers. So I have 5 functions and we want to know which ones have 1, 0. 1, 0 means it has one x-intercept. And so what I'm going to do is graph all of these and see which ones have one x-intercept, exactly 1. So I've graphed all 5 choices, and I can see that the purple function touches the x-axis once, and the blue function touches the x-axis once. The other ones either touch it twice or not at all. So the green one doesn't cross the x-axis at all. The black and red ones cross it twice. So the purple and blue ones have exactly 1, 0 because they have one x-intercept. So I would choose 9 times x minus 8 and x squared minus 8x plus 16. So this is one where I would actually click them on the program, and that would lock in my answer. I'm not going to graph this one, but you can if you want to. This one is very similar. We want to know which of these functions has an x-intercept of 3. That's a similar version of what we just did, where we're looking for 1, 0. Here we're looking specifically which of these functions crosses the x-axis at 3. I would just graph all of these and select the ones that cross the x-axis at 3. And it is this is a good time to remind you, we talked about this function notation f of x. When we have a bunch of functions we're talking about at the same time, we give them different letters at the front. It doesn't mean they're different things. We're just trying to differentiate between the different functions. So before you move on to this practice, please do ask for help if you have questions. If you don't have any questions, if that was helpful, then move on to these practice items. Give them your best shot. Ask for help while you're working on them if you're stuck, because the SOL is coming close.